Every app you use today, YouTube, Instagram, Google, handles millions of users simultaneously. How? System design is the art of architecting software that scales. Load balancers, caches, distributed databases, message queues, content delivery networks. These aren't just infrastructure concepts. They're the difference between an app that crashes under load and one that serves a billion users without breaking a sweat. Today, we build that mental model. Scaling starts with a single server. Your app, database, and files all live on one machine. This works until it doesn't. Vertical scaling, adding more CPU and RAM, hits a ceiling fast. The answer is horizontal scaling. Add more servers. But now you need to route traffic between them. That's where load balancers come in. A load balancer sits in front of your servers and distributes incoming requests using strategies like round-robin, least connections, or IP hashing. If one server goes down, the load balancer routes around it automatically. Caching is the single highest leverage optimization in system design. Instead of hitting your database on every request, you store frequently accessed data in memory. Redis and Memcached can serve millions of reads per second, 100 times faster than a database query. The challenge is cache invalidation. When data changes, how do you ensure users don't see stale data? Common strategies are write-through, update the cache when you write to the database, and time-to-live expiry, where cache data automatically expires after a set interval. At scale, your database becomes the bottleneck. Relational databases like PostgreSQL handle complex queries with ACID guarantees, atomicity, consistency, isolation, durability. But they struggle to scale horizontally. NoSQL databases like Cassandra and DynamoDB trade some consistency for massive write throughput. Database sharding splits your data across multiple servers. Each shard handles a subset of records. Read replicas offload read traffic from your primary. The architecture choice depends entirely on your read-to-write ratio and consistency requirements. Message queues decouple the components of your system. Instead of service A calling service B directly and waiting for a response, A drops a message into a queue and B processes it when it's ready. This enables asynchronous processing. It doesn't block waiting for B. RabbitMQ, Apache Kafka, and Amazon SQS are the major players. Kafka is particularly powerful for event streaming. Every user action becomes an event that multiple services can consume independently, making your system resilient to individual service failures. A content delivery network solves latency by putting your content physically close to users. Netflix doesn't serve video from one data center in Virginia to users in Tokyo. They cache content in edge nodes in Tokyo, Singapore, and Seoul. When you press play, the video streams from the nearest edge node. Milliseconds of latency instead of hundreds. CloudFront, Fastly, and Cloudflare run networks of thousands of edge locations globally. Any static content, images, videos, JavaScript bundles, should flow through a CDN. Microservices break your monolith into independent services. Instead of one giant application, you have small services, user service, payment service, notification service, each deployed and scaled independently. When your notification service has a bug, it doesn't take down payments. When checkout traffic spikes on Black Friday, you scale only the payment service. The trade-off: distributed systems are harder to debug. Network calls replace function calls. You gain resilience and scalability, but pay in operational complexity. Great system design isn't about using every pattern you know. It's about choosing the right tool for each constraint. Start with the requirements. What are the read versus write ratios? What's the consistency requirement? What's the latency budget? Then design for today and build in flexibility for tomorrow. Every Facebook, every Uber, every Twitter started as a single server. They scaled as demand required. Build for where you are. Design for where you're going.